Alright, so in this video I'm going to go over how to do gas stoichiometry when it's not at STP. So when you have gases that are at STP, STP is when you have 1 atmosphere of pressure and when you have 273 Kelvin. Well, when that happens, you know that 1 mole of a gas is equal to 22.4 liters, and you can use that to do any kind of stoichiometry or conversions. Well, if it's not at STP, you have to use the ideal gas law with stoichiometry if you're going to a different substance, and I'm going to show you how to do that. So normally in conversions, if you know it's at STP and you're dealing with a gas, you can use this conversion, because this will be true if it's at 1 atmosphere and 273 Kelvin. If it's not, you have to follow a different process. Alright, so when it's not at STP, it's going to be 22.4 liters of a gas is equal to 1 mole. Well, if T doesn't equal, the temperature isn't 273 and P is not 1 atmosphere, any kind of stoichiometry, so when you go from one substance to a different substance, will involve the ideal gas law. So the only thing is you need to figure out when you're going to use the ideal gas law, if you're going to use stoichiometry first or if you're going to use ideal gas law. Well, you're going to use stoichiometry first when you're looking for liters of a gas. And if you are not looking for liters of gas, so if you're given liters of a gas, you're going to use the ideal gas law first. So you use stoichiometry when you're looking for liters of a gas, and then if you're given liters of the gas, you're going to use the ideal gas law first. Alright, so let's look at an example. So what volume of hydrogen will react with carbon at 981 torr and 334 degrees Celsius to yield 42 grams of N-pentane? So the thing is, right here it's saying it wants a volume of hydrogen. Okay? And then it gives you an amount of something else. So it gives you a mass of pentane, which is C5H12, and that's 42 grams. This is how you know that stoichiometry is involved here, because it's asking for one substance when it gives you an amount of a different substance. So since it's asking for a different substance, you know stoichiometry has to be involved here. And I also know that I'm probably looking at the ideal gas law because, well, it's not at STP. The pressure is not 1 atm and the temperature is not 273 Kelvin. So let's go ahead and pull out the rest of the information. It says that I'm at 981 torr, so my pressure here is going to be 981 torr. So when we're looking at these variables, we have 981 torr. We also have a temperature of 334 degrees Celsius. Alright, so when I'm looking at this equation, I am looking for a volume, so that means that I will use stoichiometry first. And I know that because if I'm looking at this problem right here, I know that I'm going to be using the ideal gas law. The ideal gas law is PV equals nRT. Alright, so let's see what I have here. I have pressure. I have temperature. And then I'm looking for the volume of the hydrogen gas, but I don't have the moles of the hydrogen gas. So I need to get the moles of the hydrogen gas in order to use this. I cannot go in there and put the 42 grams and convert it into moles and then solve for that, because that's going to give me the volume of the pentane. And I want to get the volume of the hydrogen gas. So in this case, I'm looking for a volume, so that means that I'm going to use stoichiometry first. So I'm going to go from pentane to hydrogen, and because ultimately I want to use moles here, I'm just going to go to moles. So I'm going to go from my grams of my pentane to moles of hydrogen gas. So I'm going to go to moles of my substance that I have first, and then I can go to moles of the hydrogen gas. And I'm going to stop here because I want to use moles and the ideal gas law. So I'm going to start with my 42 grams of pentane, go to moles. One mole is equal to 72 grams here. I got that from the molar mass. All right, then I will go to moles of hydrogen. Moles of pentane will be at the bottom. And then moles on top of moles, that means I use the coefficients. So it's 1 mole of pentane for 6 moles of hydrogen. So when I go through this calculation, I get 3.5 moles of hydrogen. Okay, so now I have N of hydrogen. So you need to be really careful about this. When you plug this in, this information into the ideal gas law here, if I plug in an amount of pentane, I will get the volume of pentane, not of hydrogen gas. So I'm going to go ahead, I'm going to plug this information in, the ideal gas law, and solve for the volume of hydrogen. So my pressure, I got to convert. So if I convert this, 1 atm is equal to 760 torr. So my pressure is equal to 1.29 atm. And my temperature, if I add 273 to 334, that's going to give me 607 Kelvin. All right, so now I've got enough information, everything's converted, I can plug it into the PV equals nRT. So P is 1.29, V is unknown, I'm looking for V of hydrogen gas, N is what I just solved for here, it was 3.5, R is 0.0821, and then my temperature is 607. So when I go through and calculate for the volume, I will get 135.2 liters. And if I round to sig figs, it should just be 135 liters. Okay. So remember, if you are looking for a volume of a gas and it's not at STP, you will use stoichiometry first, and then you will go back and use the ideal gas law. All right, so let's look at another example. All right, so it says how many grams of Al2O3 are formed when from 15 liters of oxygen and 97.3 kilopascals at 21 degrees Celsius. All right, so let's pull the information out. I'm looking for grams, so I'm looking at mass of Al2O3. I was given volume of O2, that was 15 liters. And see, this is how you know stoichiometry is involved. I was given an amount of O2. I'm looking for an amount of a different substance. So I have to use stoichiometry somewhere in here. All right, so it also tells me that my pressure is 97.3 kilopascals. And my temperature is 21 degrees Celsius. Okay, so I have this information. And I want the mass of Al2O3. Well, in order for me to find the mass of a different substance, I need to have an amount of O2 gas. So I was given enough information to figure out an amount. I can't use stoichiometry yet, though, because I'm not at STP. So I'm going to use the ideal gas law first, because with the ideal gas law, I can figure out the number of moles of oxygen gas, and then I can go to my new substance. So whenever you're given a volume, you're going to use the ideal gas law first. So I'm going to solve for my N of my oxygen gas, and of course I have to do my conversions. So 1 atm is equal to 101.325 kilopascals. And when I do that calculation, I get 0.96 atms. 21 degrees Celsius plus 273 would give me 294 Kelvin. All right, so I'm going to plug it into PV equals nRT first and solve for N. So pressure is 0.96. volume is 15 liters. N is what I'm looking for. I'm looking for the N of O2. R is 0.0821. I'm going to multiply that. I ran out of room, so I'm going to multiply that by the temperature, 294. So when I go through and do the calculation, I am going to get 0.596 or 0.97 moles of O2. Okay, so now I have the amount of O2, I can go to my mass of aluminum oxide. And I'm going to do that with stoichiometry, of course, because I'm going from one substance to a different substance. So I'm going to start off with 0.597 moles of O2. I'm in moles already, so I can go to moles of what I want, which is aluminum oxide. Moles on top of moles, I pull those from the coefficients, so 3 of those for 2 of those, and then I just go to grams. So the molar mass of aluminum oxide is 102, roughly. All right, and then when I go through, do the calculation, I get 40.5 grams, or I'm going to round up 2 sig figs, so 41 grams of aluminum oxide. Okay, so when you're given a problem and it's looking for a different substance, you know that it's stoichiometry. So if you're going from one substance to a different substance, you know stoichiometry has to be involved. Normally, you could just use, if it's a gas, you could say that 1 mole is equal to 22.4 liters if it's at STP. If not, you have to use the ideal gas law. The ideal gas law, you're going to pick which to use first, stoichiometry or ideal gas law, based on what you're given. If you're given a volume, ideal gas law first. If you're looking for a volume, then you're going to be using stoichiometry first.